Welcome to DBA Workshop channel. If you haven't subscribed to this channel, please subscribe. Let's start. GIS in agriculture. Topics. What is GIS? GIS means Geographical Information System. It is a structured integration of hardware and software. It is a systematic way in which we talk about spatial data and its operations. For example, if we are collecting a spatial data and we are capturing it, we are storing it, and we are displaying it, and we are also have to update spatial data, we have to manipulate it, and we have to analyze it. All those things are studied and done in GIS. The subjects where we study GIS, these are the subjects where we study GIS. So why we need a GIS? Because we have a different kind of sources where we have a spatial data and we have to integrate it. So it deals with the real life, and data is continuously keep on changing, and we need a quality data, and we need a system where we could capture this data and we could retrieve it as and when we require, and we also need a manipulation on this data so that we can be used it, analyze it, and use it for our benefit. So when we store a spatial data, we have to store the features about that data. So data about data, that means features about a data, is called a metadata. So when we store the spatial data, we have to store the metadata, that means features about that data with those spatial data. GIS field relies on these four fields: computer science, database, statistics, and artificial intelligence. GIS components: hardware and software. In order to create a GIS, we need a hardware and we need a software. All the graphical devices we use to store a GIS and manipulate a GIS and analyze a GIS are called hardware. These devices could be plotters, scanners, it could be different kind of processors, CPU. We also use 3-tier architecture application for GIS. 3-tier architecture means we have a client machines, that is a client machines, and then we could have a middleware where we have a web servers, and then on the top of it we have a servers. So that create a 3-tier architecture: client, middleware, and server. Software. GIS also require a software to store and manipulate the data. For example, DBMS. We have a different kind of GIS software available. DBMS also provide features to store GIS. For example, Oracle Spatial Database. Data. What kind of a data it is? If we talk about a coordinates, it is a vector data. If you're talking about two or more points and connecting them, we are creating lines, and with the help of lines, if we are creating a closed set of lines, we are creating polygons. So that category we call vector data. What are vector layers? Vector layers means, for example, digitized maps or features extracted from images, for example, aerial images, satellite images, and scan map images. If we're talking about layers, that is called vector layers. Next, raster data. Raster data is a continuous grid of cells. It could be in 2 dimension, it could be in 3 dimension, for example, cubic cells. Example of categorical raster data is like if we are storing soil type, vegetation type, and land suitability. So for example, if we store the coordinates of a field and we have to find what kind of land for that particular coordinate, so that means we are talking about a category of that coordinate of a field, and for that we require a category table. So these kind of data we call it raster data, categorical raster data. Sometimes we are talking about elevations, so we use a digital elevation model, and we are talking about of each pixel or of each coordinate what kind of a elevation value. So that is studied in continuously raster images. So this kind of a data is continuously raster images. Next, people who are using the GIS and people who are just creating the maps, like a cartographers, surveyors who just survey the land and updating the GIS system and creating the GIS system, and the users of GIS system who are using and manipulating and analyzing the data over there are the people who use the GIS system. Characteristic of data in GIS. Since we are talking about a spatial data, so it has some kind of a characteristics. This is a complex part. If we are talking about a topological and spatial relationship and its integrity rules. For example, if we have a coordinate, points, lines, or polygons, so we have to store the coordinates related to those points and what are its location and what are its features related to those points, lines, and polygons. It is also time based because model may change over time. It is a dynamic data and quantitatively quality. It also requires what kind of a quality we have. For example, accuracy of spatial coordinates, the position of objects, how accurate it is. It also deals with how we create a 3D objects like polygons and its facets. It also talks about thematic values. I mean, what kind of property and quality of that objects. It could have a fuzzy objects. We are not very sure what kind of a location and attribute it have. Then we categorize it as a fuzzy objects. Entity data. For example, if we are talking about a forest, rivers, roads, and buildings, so we call it a entity. A data related to those entities. Field-based data. For example, if you are talking about a terrains, then its attribute vary in space, so we call it field-based data. It also store data quality. I mean, how accurate the data is, and quality and quantity with respect to coordinate and position of objects. GIS has some kind of a constraints. For example, if you're talking about entities or coordinates, so obviously these entities would have some relationship with the other entities and relationship with the features. So those kind of constraints we have to maintain. We cannot simply store the coordinates. We have to study what kind of relationship with those objects with other objects. So these constraints has to be followed when we store a GIS data. Topological constraints. For example, if you are storing about a buildings and buildings, we have a concept of a parcel. Parcel means it is a kind of a lines and polygons. So lines and polygons are stored in such a way and we call it a parcel. So for example, we store buildings by using the lines and polygons, and we have some kind of a rules that parcel boundary cannot cross the building outline, and building two buildings can share an edge. These kind of rules or constraints or restrictions have to be followed. So these are the conditions and rules has to followed when we store spatial data. Temporal constraints, this means time based component of it. For example, if you're talking about a bridge, so we are storing, we are not only storing its location, we are storing what kind of a location, coordinates, its geometry, and its time component also, what changes occurred over time. So these things also need to be maintained when we store a GIS data. So we already know it is a geospatial data. That means a data that has a geographical component. Okay, let's talk about a GIS in agriculture. This is a requirement that we require a cost-effective solution. We require to know what kind of climate conditions. We need to know what kind of seeds and what kind of yields we could have. We need to know what kind of resources we have. So this kind of data we need to collect, we need to track that data, and we have to analyze those data to do the improvements. So we do the research on it, we do the planning, and we apply the results based upon our research and planning. To do this, we use natural resources like soil, water, livestock, plant, genetics, fisheries, forest, climate, rainfall, and topology. We study all those things with the help of GIS so that our goal can be achieved. For example, if you are talking about agriculture mapping, the goal is to provide a protective environment and provide a excellent nutrition crops. So first of all, we need to estimate what kind of a crop yields we could get from here, estimate what kind of a soil health we could have, identify what kind of erosion problem we could have, and what kind of its remedies. To get an accurate crop estimate and avoid the losses, we need agriculture mapping. So this agriculture mapping using GIS is very good for productivity. It also provides employment, and it also increases the income of farmers. GIS uses different kind of tools. It 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 uses it can be uses online web resources. So the main function of GIS in agriculture is to just do the welfare of farmers, and it increases the productivity, employment, and income. It also can help in forecasting using multi-spectral imagery collected by satellites. Again, GIS helps in analyzing the environment, visualize the environment. It can do the remedy in time. It can help in creating the workflow. It maintain the soil. It can help in maintaining the soil nutrition and plant health. It helps to boost the agriculture industry to avoid losses. GIS help in better management of land and its resources. GIS in agriculture. GIS helps in analyzing the environment, visualizing the environment, and finding the problems and its remedy before the losses occur. So hence it increase the production and reduce the cost. For example, agricultural GIS, it's a crop monitoring technology. It monitor the crop. It just to do the management of the soil. It just to how better we can do the irrigation of farms. It uses geometric technology. This technology is used to create the maps. It can identify the problems. It just create the samples of current and future variation of various features of the field positions. Geometric technology is used, for example, to know what kind of a temperature on various field positions, and it can just monitor the crop. It can see that uh, what kind of problems in which section of the field, and it can based upon those data we can just do the remedy before the losses occur. So why we need it? Its goal is to do the accurate mapping of the geographical and geological features of the farm. It helps the scientists and farmers to create more effective and efficient farming techniques. It helps in taking the corrective action in time. For example, better utilization of the fertilizers, treating pest and weed infections, and protecting the fields and nature resources as well. One example is just a smart farming. Smart farming means using the sensors in the field, and it also uses the satellites. So based upon this, it just continuously collect the data, and by doing this advanced technology data collection, uh, farmers can easily know where to use what kind of resources. It can know that where are the nutrients are less, where the crop health is not good, or where the crop health is very good. So it can uh, do the remedy action before in time. So this just boosts the productivity and helps the farmers a lot. Nowadays farming is getting more advanced. For example, using these precision equipment, Internet of Things, sensors, actuators, geopositioning systems, and big data, and unmanned aerial vehicles, and use of the robotics, etc., helps a farmer a lot. Benefits of precision agriculture: it helps the farmers to timely collect the geospatial information on the soil plant requirements, so it can do a site specific treatment, and helps our farmers to do a corrective action. So in turn it helps in increasing the agriculture production and protect the environment also. Smart farming is the use of high technology tools that are more accurate and cost effective and user friendly.